Hello and welcome to the SETI Live. My name is Bettina Forget. I'm the director of the SETI Institute's Artisan Residence Program. With me today are our guests, the award-winning artist Ron Miller and my colleague Franck Marchis, who is the senior planetary astronomer at the SETI Institute. Today we're talking about the solar system's many enigmatic and gorgeous moons, many of which are featured in Ron's new book, Natural Satellites. This fascinating tour of our solar system's moons leads to compelling questions about the possibility of life on these celestial bodies. Could extremophiles hide between Europa's icy crust? May there be creatures flourishing on Titan's arid surface? We will discuss this shortly. Before I introduce our guests, I would like to welcome all of our viewers who are joining us from around the world on YouTube, on Facebook, and on Twitch. Tell us in the comments where you're from and start thinking about some questions you'd like to ask Ron and Franck, because we will get to those at the end of our chat. So let me introduce our guests. Ron Miller is the award-winning author and illustrator of more than 60 books. In addition to the art he creates for his own books, Ron has also illustrated dozens of others, including the best-selling Zoomable Universe. He is also a regular contributor of art to magazines such as Astronomy and Scientific American, and has been a production designer and illustrator on films such as Dune and Comet Impact. And he has been a member of the NASA Fine Arts Program. Miller's Pluto postage stamp attached to the New Horizons spacecraft has now traveled farther than any stamp in postal history. However, my favorite quote about Ron Miller is by Arthur C. Clarke, who said, "Ron Miller is unfairly talented." And Dr. Franck Marchis is our senior planetary astronomer and chair of the Exoplanet group at the Carl Sagan Center of the SETI Institute and chief scientific officer and founder at Unistellar. And my favorite fact about Franck is that the asteroid 6639 was named Marchis in honor of his discovery of the first triple asteroid system. Welcome to you both.
Thank you.
And remember to unmute yourselves.
I did.
All right. Ron, tell me, you made 60 books so far, most of them inspired by astronomy. Why this book, Natural Satellites?
Well, the moons of the solar system are my favorite subjects, partly because they're often ignored. There's footnotes. You talk about Jupiter and its moons. You talk about Saturn and its moons. They're always, added. No one's ever really focused on the moons before in a book. So I thought it's about time somebody gave them front stage. So.
Yeah, and I mean, they are absolutely beautiful and also very accurate. And when I look through your book, you intersperse actual NASA imagery with your own illustrations, and this nearly seamless. I mean, the art that you're producing, you can't really tell if it's, wait, is this a photograph or is it not? So it's very scientifically accurate. How do you make your images?
Oh, how I make them is complicated. There's a little bit of traditional art, drawing and painting, a little bit of digital. Sometimes there's actual 3D models involved, and it's all kind of cobbled together. And probably the easiest answer would be just raw talent.
Yes, indeed, raw talent. But I find it really interesting that you're using data. So where do you get your data from?
Everywhere I can. NASA, of course, mostly, because that's they're the only ones having flybys of these satellites and landers. So it's a combination of NASA information, and sometimes I'll try to talk to the individual astronomers as well whenever I can. And then extrapolation from what I know places are like.
And I think that's really interesting, because this is really where you come in as an artist, because you're filling that gap between what scientists describe to you, where we don't have photographs yet, and your own artistic interpretation.
Yeah, what I tried to do is make these flyby pictures, for example, NASA will take, comprehensible, because you're looking down on something when you're doing a flyby or an orbiter. So there's no real sense of scale. It's like touring the United States or Europe from an airliner. It's not the same. Seeing the Grand Canyon from 40,000 feet is not the same as seeing it from the North Rim. So I try to put people on the surface and they'll look at a feature and say, oh, that's what I was looking at in the photo. So the photo becomes comprehensible, and then the photo adds verisimilitude to the painting. So they kind of reinforce each other.
Also, that's this shift of perspective that you're bringing everybody down into the landscape. So you have that sort of first-person shooter kind of perspective rather than looking from the top.
It's a human point of view. We're not used to looking at things from the sky. So putting people, the viewer, on the ground in a place, in a position that they're familiar with, makes these places seem real and not just blurry photographs or, little black and white pictures from a spacecraft. So that's really the goal, is to make these places seem like real places.
Yeah, and they really do. I know that you are a member of the International Association of Astronomical Artists, right? The IAAA.
You bet.
I know that because I'm was a member for a long time as well. I think I still am. And I remember going on field trips to places that are looking kind of alien. Have you gone to like IAAA field trips, and have they inspired?
I've gone just to a very few. And that's actually a very important point I bring out in the book, is that there are analogs on the Earth of every place in the solar system. The only thing that's really different is the scale in most cases. So that's why studying, the moons is important, because they're little analogs of the Earth. They're places on the Earth that look like these moons, but by the same token, there are places on these moons that look like the Earth. So because we all belong to the same family. And it's like, you studying your aunts and uncles and cousins helps you understand yourself better.
So before I ask the next question, I just want to sort of do a shout out to all the viewers who are joining us and getting this long list of phenomenal places where you're all from. Serbia, rainy Montreal, where actually I am, Indonesia, Bulgaria, Scotland, where I'm sure it's often raining as well, Indiana, the Bay Area, Arcadia in Greece, Puerto Rico, British Columbia, Colorado, and Romania again. So
hi, everyone.
All over the world. This is really phenomenal. So I'd like to transition to talking about the moons themselves. And this is also where Franck comes in. Let me ask you this, between the two of you, what's your favorite moon and why? I know both of you have favorite moons, which is why I'm asking.
I'm very, very fond of two, really. Titan, it just absolutely fascinates me. I've done a dozen pictures of Titan. I think the second one might be Io, just because it's doing something.
So what is it doing?
It's exploding. It's turning wrong side out. That's what it's doing. So, which is pretty cool.
Franck, what about you?
My case is obviously Io, because I did my PhD thesis on this topic. I study volcanic activity of Io using ground-based telescope and adaptive optic systems. So in 2001, we detected the most energetic eruption ever witnessed in the solar system. We call this eruption CERT 2001. Wow. And basically we saw it live at the Keck Observatory. That was, I think that's one of the highlights of my career, when we observed Io, and it was completely different because we observed it 2 days before. We observed it then, and it was radically different. There was a gigantic eruption in the middle of it. And that's, that was a kind of an highlight in my career. We discovered that, and yeah, it's an amazing world. It's in eruption continuously. There is like a ring of fire. The volcanoes provides a lot of colors on the surface in visible light. It looks very different to any other moons. You see Io, you know this is Io, no mistakes. And then the silver medal will go to Enceladus, because it's snowing there. And I think if there is one place in the solar system where we're going to find life, that would be probably on Enceladus.
Oh, interesting. And so it's for you, it's a story of fire and ice, fiery
Yes,
Io and ice.
exactly.
Ron, what is your silver medal?
Pardon?
Which one would you award the silver medal after, like Io?
Oh,
Io?
well, he brought up Enceladus. Now that I forgot about that when he asked me the question, because I'm very fond of that too. So I might have to think about Enceladus first, even before Titan.
And I think one of the sort of, for me, the most fascinating thing about our solar system moons, aside from the fact that they're gorgeous, and I'm also a big fan of Io just because it looks like a pizza quite a lot.
Bill Hartman, the astronomer, said that Io looks like there's nothing wrong with it. The shot of penicillin wouldn't fix.
Actually, we just got an interesting question from one of our viewers. Is there a video of an eruption on Io? Is that something like an animation, something that we could see?
We do have a video of the plume of, I think it's Pilan, the volcano Pilan. You see the plume. This was taken when the spacecraft New Horizon fly by Io in 2007, I will say. I'm very bad with numbers, but took pictures, and you can see the plumes, and you can see the motion of the plumes. Google plumes of Io and videos, that's the first thing that's gonna come out. We published this in 2006, 2007.
All right, that's really phenomenal. But the thing, what I like about, Io, probably there won't be much life. It'll be roasted, right, by its environment. But there are other moons that are really promising because, like in your book, Ron, you're saying, follow the water. There's a lot of water up there. So in your estimate, if you had all the money and you were in charge of NASA and you could fly a probe somewhere or maybe go there, where would you go if you were looking for life?
Probably either Titan or Enceladus. One of those two. Well, Titan has all the chemicals. I mean, it's really the same chemical bath that the Earth was bathed in, when life first formed here. It's got a source of energy. It's got all the materials that's needed. Enceladus has the same thing. The right chemicals, source of energy, and water. In its case, it's buried under the surface. There's no light. So I think both have the same qualities, just in different ways.
I think it would be a great opportunity actually to show some images. I know, Ron, you got a whole desktop full with images lined up.
Yeah, I put every picture in the book on a file here. So
if you have anything, maybe of Enceladus or
sure.
One of those ice worlds, and just put us on the surface there.
I'll show you two or three things and come back to this.
Yeah.
So I would just would like to say something about Enceladus and the question you asked. If I was in charge of NASA and I was flyby a moon, I will fly by through the geysers of Enceladus to analyze them. Titan is an amazing world, no doubt about that. But to understand it, you will have to stay there and observe it regularly.
Through the middle, right there.
Yes, that's where I will go.
This was actually one of the first illustrations I ever did of Enceladus, probably a dozen years ago for Scientific American. And those plumes absolutely fascinated me. Seen from the surface, they have to be one of the prettiest things in the solar system. Or at least as I visualize them, I think they would be. I see them as big, feathery plumes, expanding into the vacuum of space.
What is interesting about this image is that you have to take into account that there's probably not the same kind of atmosphere. So normally you think of a geyser and you think of a geyser as it would behave here on Earth, but the conditions, of course, they are completely different. And also the light conditions are very different. And I love how you sort of have that sort of iridescent, pinky, turquoise glow there.
Yeah,
as
there's
well.
a little sundog, you know, and the ice crystals. Yeah, according to, I talked to Carolyn Porco about some of the details about these paintings of Enceladus. And apparently this stuff comes rocketing out of these fissures with pretty much the speed of a jet engine exhaust. So they come blasting out of the surface of Enceladus. And probably, because it's exiting into a vacuum, this probably expand immediately into these, you know, huge fans. I'll be disappointed if they don't look that way, but that's how I think they would look. It's one of those educated guesses I have to make as an illustrator.
Mm-hmm.
By the way,
we need to remind people here that we are talking about a body which is 400 kilometers in diameter. Yeah. There is almost no gravity. And that's the reason the plumes are so big and extend so far away from the surface. Yeah, you have an ejection of material.
I have two little astronauts here.
Oh, I didn't see that.
One of them is hanging on for dear life because it's such low gravity.
Actually, I have a question about from our viewers about Enceladus. And our viewer asked, are there smooth and huge icy surfaces on Enceladus? I'm trying to imagine astronauts skating across hundreds of kilometers of smooth icy surfaces.
Who's that? Who wants to answer that? I don't think it's not smooth.
It's not smooth at all.
Enceladus is pretty rugged. It's pretty rugged
because of the lack of gravity, basically, and the activity on the surface. There's probably some kind of not plate tectonic, but deformation due to the interior activity, especially close to the pole. And there is no erosion plus very small gravity. So you have very sharp cliff. It would be very difficult to explore those moons as a human being walking on it because of that. Plus, recently we discovered that it's snowing. And this snow can be like meter high. So imaging a world like that is gonna be a nightmare for people to explore. We step on the snow and we have no idea if there is a gigantic crack here or a cliff and you collapse. So it could be extreme.
Wow. Yes, very extreme. So Ron, tell me about this image. This is gorgeous.
Well, this was Enceladus again. This is very speculative, of course. But these are some hydrothermal vents under Enceladus's ice crust. Sort of like the hydrothermal vents, you know, the smokers, you know, we'll see at the bottom, you know, during some geothermal areas under our oceans. And not only is warm water bubbling up, but a lot of, you know, released chemicals are being released into the subsurface ocean as well, which all combined, once again, are good signs, you know, hopeful signs that this could be a place where life could evolve.
Well, and if you look carefully at this illustration, I see a little bit of green there at the sort of ocean floor. So are you already speculating that something could live there?
Wishful thinking.
Yeah, I'm all there for it. I'm all for the wishful thinking.
So that was my question, in fact, for Ron, that I wanted to hold for the end. But so when you paint things like this, you probably have some moment you say, which color I'm gonna use for that?
Yeah, I kept it subtle because I didn't want to draw that much attention to it because I didn't want to, you know, have the readers, which are supposed to be young people, you know, jump to the conclusion that there is life on Enceladus. But I wanted to hint at the possibility in the back of their minds.
Yeah, and I would like to just pause and do shout outs to our audience again and say hello to Duisburg in Germany, Sweden, Washington, DC, Spain. Somebody said Mars. Really? There's a little bit of a delay then without transmission. Paraguay, And thank you for our listener who has made a donation from Colombo and Bell sent 50 stars. Thank you. You guys are awesome. So actually
this is for you, Franck.
Yeah, that's for all of us. So I have another really cool question. If the moon is so small and the jets are so big, does their thrust change the orbit? This is like the jets on Enceladus, because they come, I mean, it's a tiny moon. The thrust is huge. So does it nudge maybe the orbit? Is that
so there is the idea that the moon of Enceladus, kind of the obliquity of Enceladus, we call this, which is basically the orientation of the moon with respect to its spin, change over time because of that. That's what you can see.
That's amazing. Ron, don't stop sharing if you got.
Oh well.
Oh yeah.
I didn't want to
like
no
say
problem.
hi to our listeners. No, keep going. I mean, it's beautiful. What else you got?
Oh, I got plenty. Actually, I literally have thousands. These are just the ones that are in the book.
And thanks for the sneak peek, because the book just came out last week, right? So
last Tuesday.
Oh, and now we've got 200 stars.
Here's another
amazing.
Another IO for you.
I love this one.
I think part of my fascination with illustrating IO is I just really, really like painting lava and eruptions. So it's not so much the moon itself as the stuff going on it, which is a lot of fun to do.
So this reminds me that the eruption we discovered in 2001, and I was looking for an illustration at the time. We did a press release when paper was published in 2002 or 2003, and we did not find any. I didn't know you at the time, but I would have asked you to do that, because the eruption, we knew from the profile of the eruption that it was very young and extremely active, and we derived, that was a work done with Ashley Davis from JPL, that it was basically fire fontaining, so this kind of eruption, covering an area as big as Los Angeles in less than a day. So that's the way we now, in fact, we had sent people at the time to observe CERT, the source of the eruption. I think that's something like this that this person will have seen, this kind of activity. So thank you, Ron, for making an illustration for our eruption 20 years later.
Always
make the calculation.
Actually, that's a really great question to you, Franck. When you're seeing illustrations like this, does it help or sort of inform your own research? Does it help you to visualize what it is you're working on? Because like Franck's, like illustrations like that are great for science communication and public outreach. But I wonder if also the scientists who are researching all these moons are also getting something out of seeing their data being made into images.
Something that this can do is to give us ideas. In fact, when you see those fire fountains, I noticed that you, for instance, you put a different leveling into the source of the fire fountain. And I do remember that we have seen that. We think we have seen that. We can see that the source of the fountain is not at the same level. It's slightly changed because we saw the orbit. We saw the variation of the intensity of the source changing with the rotation of Io. This could be the source of that. In fact, because you don't see, it's not perfectly, what I'm trying to say is that the source is not a perfectly flat surface. It may be a surface with some kind of rugosity like you have here. And that's what we were seeing when we see the variation of the intensity with respect to the rotation of Io. So I just got this idea looking at this eruption, for instance. So I think this is useful because of that. We can get ideas for having artists doing things like this and taking the liberty of adding details that we did not think about.
You make me feel so intelligent. Now there's similar, illustrating some similar processes on Titan, which I like a lot. This picture is supposed to show just after a methane rainstorm has passed by. So
wow, the clouds after the storm.
Liquid methane Yeah, so yeah, it's after the storms. So there's methane, little methane waterfalls here, and it's all running down to this methane river that's flowing down to this methane sea. And some of the storm is still out here, still raining.
Wow. And how do you decide on the colors?
Well, the place is orange. it's the color it really is, which is, all these organic molecules that are just plastered all over the surface of Titan.
And in the
It's
atmosphere.
all yellows and oranges and reds, which are typical, it's sort of a sign of organic molecules are those colors.
We sent a lander on Titan, the Huygens mission, and the picture show that it's an orange world because of the absorption of the particles from the haze and in the atmosphere from haze and small dust. So you probably use this kind of colorish orange for your illustration, as I can see from the sky here as well.
Exactly.
I got a really interesting question
This
from
is,
one of our viewers. Has anybody ever tried to do a virtual reality visualization? Like, you do a lot of your illustrations like from that human perspective. Especially like at your Enceladus work, it's so detailed. It could be a really interesting experience.
I wasn't too sure. What was the question?
If any of your work has maybe potentially been adapted for VR work.
Adapted for the artwork?
Virtual reality, really stepping into your work.
Not that I know of. So,
your next project.
Yeah. Oh, yeah. I need more projects. It'd be fun to work with somebody who could do that. It would.
So, in fact, I work with a company in Europe, in France, in Nantes, working on virtual reality, and they've been using data coming from spacecraft of NASA to do virtual reality, moving on virtual reality like on Mars, but I don't think. Oh, they have done Titan too. The small area that's been observed by the Huygens spacecraft. So, Ron, if you want to start a project like this, I know the right person to talk to.
Let's talk about it.
All right. I like this. Creative collaborations coming out of the SETI Live.
Yeah. Well, this is a cryo geyser on Titan, I think, I really like the idea that a lot of these moons are active. They're not just dead balls of ice or rock. There's a geyser on Europa. But back to
that's one of my favorite moons because when I initially became interested in solar system moons, what intrigued me was that apparently there's liquid water there and also a lot of complex chemistry. So sending maybe a probe there could be maybe it was a better chance of finding life than sending something to Mars.
There's another scene on Europa. It's just fissures in the surface, and venting along one of the fracture lines.
Is this an illustration that you is that an illustration you got requested by Scientific American when the kind of activity was discovered on Europa, or that's unrelated?
I've done so many things for Scientific American. I can't remember which moons I've illustrated for them.
I have the feeling that was a picture I saw at the time.
No.
Yes. So if some of these images are familiar to some of our viewers, that is why. And I also, it's lovely to open Astronomy Magazine or Scientific American and see like Ron Miller. And I remember, Ron, when I asked you.
I like that too.
When I asked you whether you use digital or analog, and you told me this anecdote about it still being a Ron Miller painting. Maybe tell that story again.
True. Yeah, up until about 20 years ago, I did all these traditional media. They were acrylic paintings. And I had a 10-book project for the same publisher that did this book. And I had to write and illustrate 10 books about the solar system, and about one book every about 5 weeks or so. And I realized there's no way in the world I was going to be able to do this. So I bit the bullet and gave a hand at doing a digital painting, which I'd resisted doing. So I showed it around to my IAAA colleagues, and the first thing I heard was, "Oh, it looks like a Ron Miller painting." That is all I needed to hear. And I really haven't gone back since. I've just recently started doing some traditional space paintings again, but the digital art is a lot of fun. It takes just as much effort in a lot of ways as a traditional painting, just not as messy, and mistakes are easier to fix. So I learned something new every day I do these things. So they're a lot of fun.
This is Triton, right?
This is Triton.
Beautiful.
I'm glad that I can recognize my moons just by looking at the planet in the background and the color of the surface. I can recognize the color that you use on the left for the rocks, which are the color of Triton observed by Voyager.
Good.
That's such a beautiful moon.
Yeah,
it's gonna be amazing when we're gonna go there to see.
I haven't done nearly enough pictures of Triton. I've only done maybe half a dozen. I need to do more because I think it's going to be a very, very interesting place.
Yeah, it looks really dramatic. And what is so beautiful about your work is that it is scientifically accurate, but also works as a painting, right? It looks like a Ron Miller. It's a beautiful composition and colors. And at the same time, Frank can go like, oh, that is the actual color.
I was really happy to hear that. Well, I think it's important to have a good balance. Let's say they have to be accurate for what they're being used for, but they also have to work as landscapes. They have to be good art, because it can be all the accuracy in the world will be for nothing if people look at the picture and say, "Oh, somebody just made that up." Or it looks like this is a terrible painting. That would get in the way. So it really has to work as a landscape first. That just has something funny in the sky. That's all. The accuracy and the art have to be balanced.
Yeah, and I think this is so we're coming to the end of a half hour, and I hope I've been able to include as many audience questions as possible. Maybe a last one. I'm getting one like, what is Europa's atmosphere like? I think it does have a little thin atmosphere. I think, Frank, you
yes. If I remember properly, it's an atmosphere of nitrogen, essentially.
Okay.
So that's a very primitive gas. It's extremely cold over there because it's far away from the sun. So we're talking about temperature of less than 60 Kelvin. Okay, so it's very, very cold. So most of the gas basically solidify and become ice, snow ice. So that's why nitrogen is the only gas that we can have in the atmosphere. Oh, this is cool. Can we talk about that before ending?
Yeah, let's do this.
This is for my friends at SETI. It's a little submarine exploring Titan seas, looking for life.
I want to be on that mission. That is gorgeous. And I also want to do a quick shout out again to all our listeners, and thank you for your donations. Thank you, Sabine. This is really phenomenal. We really appreciate your generous support. And I'm just going to take this opportunity to remind you that the SETI Institute is a nonprofit organization, and it's due to these kind of generous donations like these that SETI live events are possible and our outreach activities are possible. So if you'd like to support us, please consider going to the SETI.org website and hit donate, because that would be much appreciated. I just want to thank both of you. Thank you, Ron. Thank you, Frank.
Oh, thank you for asking me.
And honestly, I could do this for another 2 hours, just going through like all your slides and having this little sneak peek onto your desktop. But for those of you who just love Ron's work and want to see more, just get New Horizons, the new book. I think we can put or maybe have already put the link in the chat. Otherwise, I'm sure it is available wherever you can buy books, and ideally support your local bookstore. Thank you both. It's been an absolute pleasure, and I will go and order this book now.
Thank you.
Thank you very much. Thank you, Bettina.
Thank you.